Question is, calculate the rat population for after 6 years. And we do this for a multiple year period of Leslie matrix by our new formula, which we'll get to soon. So we've got our initial population of our age groups here, and we've got our table of information. And from here, we have our required data, and now we just need to input our data into our Leslie matrix, which is right here. We've still got our initial population here. To now, all we need to do is our new formula for multiple year period, where we transfer our equation from this over here to this down here. So we've got our population after time period 6 equals Leslie to the power of 6 minus 1, which equals 5, times by the initial population. So we've got population after time period 6 equals our Leslie matrix to the power of 5 times initial population. And we can instantly see there is a difference here compared to the single year period Leslie matrix, and that is our index law of power of 5. We can solve that out by using our second step here, which is we have all these numbers here and we use all of those. So we go 0.5 to the power of 5, which equals 0.0313, 2.4 to the power of 5, 79.626, and 0.3 to the power of 5 is 0.002. And we keep our initial population over here on the side, and we need to make sure that is important because we do not touch that at the moment. Because once we get to here, we go back to our single year period matrix, and it is very similar from here on out. We just go this number here, which is technically our birth rate 1, times by 55, plus our birth rate 2 technically, times by 35, and then add this, which is our 0.002, which is our birth rate 3, to our initial population down here. And that gets us our first row for down here. And then we do these two the same, and we get our numbers down here. And we can bring them down out and add them all up. So we can find out our total amount of 0 to less than 1 year olds, total amount of 1 to less than 2 year olds, and total amount of 2 to less than 3 year olds. And we can come from this step up here to adding them all up like our first step, and we find out a number of 2,793.114, which means that there are a total of 2,793 female rats. From here, we times it by 2 to account for the amount of male rats that we have, which gets us a population after time period of 6 equals to 5,586 rats. The important step here is to notice the fact of this number here, that we've got a absurd amount of younger rats, and we need to bring that back to the fact that from the start that we need to account for that Leslie matrix is so important for younger age groups to understand, because calculating population growth is important as we can understand the potential growth of the species as it may be harmful in the future and cause issues, which is what comes in here. Now we need to talk about the fact that we've got a lot of younger rats in here, and they do not produce as much as the middle. And we have got hardly any middle rats. We've got not quite 2. And then we've got not quite 3 of the older rats. And that is a problem for reproduction rates. And then we need to remember that Leslie matrices has 2 formulas to remember, except for one. And one of them is just a shortcut for longer Leslie matrix equations. And we do need to remember that Leslie matrices is an essential for our growing future, and that we need to account for it, and that it is an important part of our growing lifestyle.